Today, what we're going to do is we are going to work on finding mean, median, mode, and range. We're going to review each of those, and then we're going to be talking about variability today. Okay? So, the first thing, what I would like for us to do is, if we have a data set, what are the 4 things that we can find in our data set? What is one of them? Max. The range. Someone else share what the range is. Tyson. Good. We're going to take the largest number in the data set and minus the smallest number. That is your range. What other one can we find? Josiah. Mode. What is mode? Talk to your neighbor and discuss what mode is. Coming back together. What is mode? Brayden. The number that shows up the most. Exactly. Okay, let's say I have 7 show up 5 times, and I have 10 show up 5 times, and that's the max. What is the mode? Macy. Good. Both numbers, 10 and 5, I believe they were, are the mode. Okay, you cannot add them 2 up and divide it by 2. Because we're looking for the number that shows up the most. If you add them up and divide by 2, that number might not show up at all. Okay, the mode, figuring out which number shows up the most. Next one. Lily. The mean. Mean is also known as altogether average. Okay. So average is trying to flatten out all of your data sets so the numbers are all the same. How do you find the mean or average? Patrick.
You add up all the numbers together and then how many numbers there are, you divide the total of numbers divided by that number.
Good. You add up all the numbers divided by how many numbers you added up. What if one of those numbers you added up was 0? Do you include the number 0 in your denominator, the number you're dividing by? Josiah? Yes, you have to include a value of 0. Okay, because if I'm shooting free throws in my basketball games and I make 3, I make 0, I make 8. I'm not just going to forget about that game that I made 0. So you have to include that game in when you divide. All right, the last one. What is the last thing that we can find when given a data set? Maggie. The median. Talk to your neighbor. What is the median, and what's one important thing you have to remember when finding the median? Go. Coming together. Voices up. What is median? Ella. Do we divide it by how many numbers there are? Tyson. The middle of a data set, okay? The center of a data set. What's the most important thing you have to remember when you're finding that middle? Brogan? Good. The data set needs to be in order from least to greatest. Now, what if your middle, your center, is 2 numbers? Macy? Good. You have to add those two numbers divided by 2. Sometimes you can just find the middle if it's like your 2 set is 13 and 14. We know the middle is 13 and a half. But if they are not very close to each other, we have to add them up divided by 2. Questions? Great job. Those are the 4 things we can find with a data set. Let's go ahead and move on to what we're going to be talking about today, and that is variability. It's a very complicated word to say, especially if you have to say it a bunch of times. So I want you to try to say variability 3 times in a row, fast. That wasn't bad. I'm impressed. Okay? Variability. Variability is describes how much the data values in a data set differ or vary from each other. We're going to look at this first graph here. This data set would have high variability. The reason it has high variability is because the data values are widely spread out. These numbers take up the whole graph. They spread out between all the numbers. We would call this high variability. The next one, it says low variability. Why would we say this is low variability? Macy.
Since they're close together and they're spread out.
Good. All these points, these data values, are lumped together. The last one, it says no variability. Why can we have no variability? Rylan. Good. All the data values are the same. So an easy way to find if it has high variability or low variability, I should say, there's no easy way to figure this out because this is very subjective. But if you draw lines over the top, if it has a big lump, is that going to be high or low variability? Tyson? It's going to be low variability. If it has one that stretches out over a long period, that's going to be high variability. Because all the data set is spread out. Questions? You have a graph at the very bottom of your front side of those guided notes. Talk to your neighbor and decide whether you think that graph is high or low variability. This one right here. Is that high or low variability?
So I'm going to say high
All right. What do you think about this graph here? Do you believe it has high variability or low variability? What I will say is, throughout the whole day, we've had disagreements on almost all problems. So if you believe it's something different, that's okay, but you better have an explanation of why you believe it is either high, low, or none. Does that make sense? As I said, it's subjective. It depends how you are looking at it. All right, Josiah, what do you think about this graph?
high variability.
High variability. Raise your hand if you agree with high variability. Raise your hand if you think it's low variability. Tom, why do you think it's low variability?
Because there's a wide range, isn't it? There's a ton of dots. And I think there's only like 7 dots and not...
7 dots and what? Keep going, you're all right.
There's and how, and that's why I think it's high variability, low variability.
Okay, good. Rylan?
I would also say it's low variability because, like, it's not all stacked up on the same number. And it's like kind of, I don't want to say like, the straight like roller coaster.
Mm-hmm.
I think it's, I just think it's low.
All right, Macy.
I think it's no variability.
It's what?
No,
No variability? Okay, why?
because there's only like 4 sections, and 2 of them have more than one, and then the other 2 have only one. And so that would also mean that 2 of them would be high variability, and 2 of them would be low variability. So since there's not another one, they couldn't like go on either side.
Okay, when we talk about high and low variability or no variability, you have to look at the whole graph. Okay, you can't point out individual points. Okay, turn to the, where you should go in the front. A no variability. What happens in a no variability? Macy,
There's only one line.
there's only one line, so all the values are the exact same, or all of our values are the exact same. Okay, so it has to be either high or low. I would say that this is high variability. The reason why I would say this is high variability is because these numbers are stretched out throughout the whole graph given to us. Okay, the graph given to us is from 9 to 28, and in that range, the dots spread out through almost that whole data section. Right?
Wouldn't that be low variability?
So they're spread out really far from each other.
Oh, never.
So that's high variability. The only way, if you think it's low variability, I would accept that if you say, I'm going to ignore my stray data value because it's not good data, and all of these are pretty close to each other. That's the only way I could say that it was low variability. You see how you can say high or low, you just better have an explanation for why you believe so. Turn your paper over to that. We have 4 different types of graphs. Well, 3 different types of graphs. We are going to go over graphs tomorrow and next week. This graph, first one here, is called a dot plot. The second one is called a histogram. The third one is a really fun one. Does anyone know the name of this graph? Hudson. You're close. It's called a box and whisker plot. And I think Hudson said cat because you can make it look like a cat. Does anyone see? That's my favorite part about boxing. And then we have again a dot plot. So with these 4 different graphs here, I want you and someone around you to either identify them as high, low, or none. No variability. So you and your partners go ahead and run through that. These 4 graphs. The first one in this dot plot. Do you think it is high variability or low variability? Jason?
I think it's low.
Okay, why do you think it's low variability?
Because on the other side, the graphs look really similar to this one, and when they're really close together, that means they're low variability.
Great, good explanation. Who thinks it's high variability? Patrick, go explain why you think it's high variability.
I think it's high variability because it covers the whole graph that it's in, like in its area, on the page, and like it.
You're good. That's your explanation. I think both of those are good explanations to explain why. I will say, if we had to choose, I would say this is high variability. Because to Patrick's point of, it took up the whole graph. We are taking up from one extreme to the other extreme. This is our low extreme. This is our high extreme. And we're using all of that space. Brogan.
But the number line has arrows on each side, meaning that it goes on forever and ever. So is it really taking up the whole number line?
Yes. Great point. To come back at you, all graphs that are on number lines will do that. So couldn't we say that for every single graph? Okay, so yeah. So that's why we're saying we're looking just at this here. This is what is given to us. Okay? Ryan.
I'm gonna go right back at you.
Oh, yeah?
On the last problem of the front of the page, not all of the dots cover up the whole entire graph.
But it is still high variability, isn't it? That bottom one is high variability. They take up a whole bunch of space. They're taking almost up the whole graph given to us. From one extreme to the other, it takes almost the whole graph. Alright?
That's not true, because there's more that aren't with dots than there are with dots.
Okay, but does it matter that it has dots or not? It's saying from one extreme to the other. We are saying we have values from 10 all the way to 28. Even though there's no dots here, that's part of our variability. It's part of how much it's varying. Okay? So that I would say this is high. I would say the only way you could say it's low is giving an explanation of how bunched up they are. I got this one incorrect when I tried it online. What do you think it is? None? If you think it's none, that's what I thought. I would say with the information that you know, we should say that it is none. Histograms are ranges of numbers. So like this first line would be 0, the second line would be 5, the third line would be 10. So in that histogram, we have a range of numbers from 5 to 10. We haven't gone over histograms yet, so it's either none or low. The third one, what do you got? Josh. Good, that's high variability. Spread out the whole thing. What about the last one? Maddie. None. That would be none. Okay? All right. Great job. Again, no homework tonight.